Okay, this little video clip is addressing the question about whether heat and temperature are the same thing. And to answer that question, we set up a little demonstration to get some data from it. So three girls came up and they put 100 mils of water in 3 polystyrene cups and took the temperature of that water prior to doing something different to each. So the first girl, I had some water boiling with a 50 gram mass in it, so I know its temperature was 100 degrees Celsius. And the first girl popped that brass 50 gram mass in and took the temperature and got a temperature change of 3 degrees. The second girl had 50 mils of the boiling water, added that, and got a temperature change of 19 to her cup. And the third girl put in 25 mils of the boiling water in and took the subsequent temperature, and that led to an 8 degrees rise in temperature. Now, comparing these beakers addresses the thing that the amount of heat involved is influenced by 3 factors. And if we compare the difference in what we did in cup 1 and 2, we've added the same quantity, because 50 mils of water weighs 50 grams, but we've added a different substance. So one of the variables that influences heat is the type of substance you add. It makes a difference whether you add water or brass to the temperature change. And in our equation that we're going to derive, that particular variable is called the specific heat. Now, specific heat's unit is joules per gram per degree Celsius, and that unit enables us to write a definition for what we mean by specific heat. So the specific heat of a substance is defined as the energy. Energy is always in joules. The energy involved with raising the temperature of 1 gram of the substance 1 degree C. And we did comment that the specific heat of water is unusually high, which has the advantage of moderating the temperature at the ocean. It takes a lot of effort to get the water temperature to rise and a lot of effort to get it to cool, so it tends to stay fairly even. If we compare, so one of our factors that's influencing heat is the type of substance, which in our equation is represented by specific heat. Now if we compare our cups 2 and 3, what we've added here is the same substance but different amounts of it. So it makes sense that another variable is the amount of substance added. And in our equation we represent that with M. And of course we know that heat and temperature are related, but they're not specifically the same thing. The link will be the equation, which I put over here. Heat is equal to, pithily you just remember MC delta T. C is the specific heat. So you can put it in an equation as C, which is an old way of doing it, or just put in SH, its initials. M is for the mass of substance heated, and usually we're doing the experiment in water, so it's the mass of water heated. We don't bother to measure the mass with a balance though, because we know water having a density of 1 gram per mil, it means that if we measure out 1 mil, we know we've got 1 gram. And of course the temperature change represented by delta T. If you have your mass in grams and you have your specific heat value as 4.18, your heat's going to come out in the unit of joules. If you wanted it in kilojoules, you divide by 1,000. So to sum up our question at the beginning, heat and temperature are the same thing. No, they're related by this equation. The heat involves the temperature change, but also 2 other substances, what we're actually heating and how much of that substance we're heating. Thank you for listening.